Welcome everyone, thank you very much for coming, especially that the conference is about PHP and this is apparently a talk on JavaScript. I expect that some of you are interested in how JavaScript works, how it evolves, and you just want to learn more. And the rest of you might be some people who have bad luck from time to time, and you need to basically wear an anti-toxic suit just to drown in JavaScript that you don't want to work in, but you touch it from time to time. You don't know what you're doing, but you just basically need to fix it and run away from it, right? So whether you're in the first group or in the second, I hope that we'll be able to uncover the magic behind async programming and that you'll learn about the foundations and how it basically works. We will speak about different classes of problems and different classes of solutions, how to match them, when to use what, how to basically make scalable solutions. Async programming is a very, very broad topic, so it's impossible to learn pretty much everything in just 45 minutes, but I hope you will get deep inspiration into what to learn next, and you'll have a solid overview on how to cope with async programming. Async programming is kind of is one way to deal with concurrent programming, which is difficult. Concurrency is basically about dealing with multiple tasks that overlap within one period of time, right? This is an art to do it the right way. Often when I join development teams, I find that people don't really understand what is going on underneath. They try to do something that might work, ended up like this. If it works eventually, it's okay, hopefully. But sometimes it doesn't work as intended, and it comes out after a week or a month or even longer. And the bugs are hard to reproduce because if there is a race condition, then the error is non-deterministic. Sometimes it can be reproduced, sometimes not. The next immediate step after it is, if I finally found a working solution, I try to convince or even prove to my colleagues that the framework that I am using is superior to other frameworks. And there is an endless discussion about the JavaScript fatigue, Angular, React, Vue, now Svelte is the framework, and so on and so forth. So there are lots of frameworks in JavaScript landscape. Basically, I try to fight this attitude about speaking about the framework because, frameworks do solve problems, but the frameworks are not the heroes themselves. The patterns are important. Certain frameworks choose certain patterns, and when we want to solve a problem, the application is not about being built in React or Angular or whatever. It's about, do we have big forms? Do we have dynamic forms? Do we have a lot of domain logic in our application? Do we have real-time events in our application, and so on and so forth? Having understood the problem, we should basically pick up the solution. And we are going to speak about the solution, let's say, one level below the frameworks. My name is Tomasz Ducin. In my work, I help developers build better software. I join teams as an independent consultant to basically help solve a bigger issue that a team might not solve on its own. I also do development trainings on stuff like JavaScript, TypeScript, React, Angular, async, architecture, and so on and so forth. If you want to get in touch with me, please drop me an email or contact on Twitter. What we're going to speak about today, the most fundamental, the most important thing in JavaScript are functions. Unlike in many object-oriented languages, you might be familiar with, obviously PHP, but also Java, Python, C#, and so on and so forth. Objects are not the most important parts. These are functions. So we are going to start with low-level fundamentals of functions being invoked in a sync or async manner. We're going to speak about run to completion rule and the event loop. Event loop is the mechanism that will basically keep JavaScript on running We can't see it, but basically this is the control flow that is inside the language. And we'll go forward to the architectures. The first one is basically callbacks. So passing a function to another function so that it will be later on called. This might be cumbersome very fast, so we might need better abstractions. One of them is promises. A promise is basically an operation that will eventually finish, but even if we don't know if it's finished or not, we do know what are the next steps, and we can define what will be the next steps even though it's not finished. If we combine multiple promises together, we can form a chain of promises. So basically, do this, then do the next thing, and then do the next thing, and so on and so forth. And promise chains are pretty much limited. Again, we need a better representation for this, and using promises which were built in natively in ES6 and generators that will also baked into the language in ES6, we have something called coroutines. By the way, if you're not that much up to date with current JavaScript, there has been a really huge growth of the language. The JavaScript that you might know from, let's say, 2010 or 2012, something like this, is now it's twice as much inside the language, or even 3 times as much. There's been like a huge growth. So it's not the language you might remember. It might look completely different, and it's not that easy anymore. It used to be easy, it's not anymore. So if we have a chain of promises which is limited, we can replace it with a coroutine. Coroutine is basically a story that will have multiple steps. One step, another step, another step. If we want coroutines to talk to each other, basically, it's kind of simulating multi-threading within one piece of code. We have communicating sequential processes. It's something that is baked in languages like Go. Go has Go routines. Basically, one thread might do something, push something into another thread, and another thread will basically wait until it receives the message. This is done in a blocking API. This pattern is implemented. You might have heard about Redux, maybe, at least the name. This is the foundation for Redux Saga, a plugin for Redux for building big and scalable applications. Promises combined together with generators form coroutines which solve many problems with promises, but they do not work together out of the box. We need to introduce a bridge. So after introducing the two in ES6, the community came up with an idea to bake this bridge into the language, and it's basically Async API. The syntax might look unfamiliar, but I hope it's going to be pretty easy in the long run. So what we can see here on the right-hand side is when we have operations that are performed once. There is one operation of type A, then there is one operation of type B, then there is one operation of type C, and so on and so forth. They are not repeated. If we have operations that occur multiple times, the same operations, we can have events. Events are nice if they are, I would call it, flat. So if there is an event being emitted, we can just display something, we can console log, we can write something to local storage or whatever. But if there is some kind of, let's say, interdependence between the events, for instance, I'm receiving events from WebSockets. I have, let's say, a currency rate being updated from a WebSocket, and I have updated, and I do receive the updated amount of a currency that I would like to buy. Then, in order to get what I can finally buy, the exchange rate, I would need to have the most up-to-date value of the rate and the most up-to-date value of the amount, right? Then, how I could make these events interdependent, like, sooner or later, I would end up having global variables or locally global variables, which we know global variables are not are not a good idea. Or it might happen that if I click something, I shoot a request with an HTTP. The problem is, if I change my search criteria and I click search again, then there are two pending requests. I might not need the former one, right? I should cancel it. The problem is, if I use promises, they do not allow me to cancel it, right? So I would like a better representation for events, and hence reactive streams. Reactive streams are probably the most difficult out of these, but if you would like to be proficient with modern JavaScript, this is basically what you can stumble upon. So this is what we're going to talk about in this talk. So first thing, if we want to build applications, the easiest thing we can go with is basically doing single-threaded synchronous programming. Synchronous means that I will have code that is basically linear, written in a linear manner, like all code is written in linear manner, but it's also executed in a linear manner. This is what we have in PHP, right? The first line has to finish so that the second line can start, right? The problem is here that if I have all the data that I need, I can proceed to the next task. But if I have to wait for something, for instance, open a file or wait for SQL to answer with some kind of data, then I have a gap of not doing anything. I waste this time, right? In PHP is not a big deal because the web server is basically spawning multiple requests, so that multiple threads, so that if one thread is basically doing nothing idle, then the other thread might consume CPU. But in JavaScript, we cannot spawn many threads, right? Because one UI has to do all this stuff, so it basically would not work. Also, if we wanted multiple threads to talk to each other, we could not choose the solution of PHP that a thread is being spawned, and when the job is done, we basically kill it, or it just dies. It's not the way, because we need to keep the state in the memory, so that whatever the user has clicked or done, it basically stays in the browser. So it's not the solution for us. But we don't want to waste the time here, because the browser would basically freeze when we are waiting for anything. And in JavaScript, everything that is difficult in JavaScript is basically around waiting for stuff. We wait for user interaction, we wait for data to be fetched. So this is no-go. If we want to reduce the problem with the gaps that we are waiting, we could introduce multi-threaded programming. It's a lot more performant, but people who has done some C or C++ or Java know that multi-threaded programming is very difficult in terms of debugging, because if I stop one thread, then the other threads are executing, and it's really, really tricky. So what JavaScript decided, what Brendan Eich has decided formerly, is we would like to solve it in a slightly easier way, and this is async programming. So basically, there is one thread, there is a single space of memory that is available, and there has to be a hidden mechanism. In this case, it's called event loop, which will basically turn the tasks. A task is going to be a piece of code that will execute at some point. There will be a queue of such tasks waiting to be executed. And this hidden mechanism that we cannot see will basically take one task of the queue, execute it until it's done. This is the run to completion. When it's done, it will ask the queue, do you have something for me? It will basically take the thing, do one thing at a time, so that we don't have problems with that we have in multi-threaded programming. We don't have to introduce any locks, because there is no possibility that two threads will basically try to touch the same variable. No possibility that I would read a variable and another core of the processor would try to write something. No race conditions like this. We would have a different type of race conditions. So, generally speaking, synchronous code is code that is written, of course, in a linear manner, but is executed also in a linear manner. So I know that as I read the code, it's going to be executed in the same order. And this is really easy to reason about, because what has been declared up front will be available later on. Async programming, in async programming, the code is not executed in a linear manner. So we might have situations that this piece will be executed, then this piece will be executed, and later we'll jump up and execute something that has been written some lines above. So this is tricky. One of the biggest challenges in async programming is not to introduce any race conditions. A race condition is a situation in which I assume what is going to be the order in which external events would happen. For instance, if I have a server that I need to shoot 2 different requests, and request A answers in half a second, and request 2 answers in 2 seconds, even if I have a server that always responds with this, within this period of time, I can never introduce any expectations on how what is the order, right? Because at least the network latency could flip the order, right? I cannot assume what is going to be the first one, what is going to be the second one, as long as the requests are competing. So the challenge here is to use certain architectures, to use certain APIs to enforce that we don't assume what the order is going to be, right? No assumptions about the order. So first thing, we can invoke functions in a synchronous manner and async manner. Basically, everything by default is synchronous, and this means if I have data that I would like to do something upon that data, I do this synchronously. For instance, if I have a list, if I have an array, map, object, whatever, I do have this data in my memory, in my RAM memory, so I can invoke the functions immediately. Only some functions, and here we have an example with a set timeout, only some functions will be delayed. So let's take a look at this example. If I have a var list 1, 2, 3, console log before, list for each, console log inside, and console log after. The order of execution here is going to be before, 1, 2, 3, and after. There is no need to skip anything, because if I have this data declared, I can immediately go inside, right? However, here, if we have a set timeout means I would like something to be moved to be done later. Like sometimes I need set timeout, sometimes I don't, but it's a general, let's say, rule of thumb about async programming. If there is a function that is that has an async API, it means that this callback will not be executed immediately. Even if I'm delaying the function with 0 milliseconds, it doesn't matter. It's going to be moved to another message in the queue. So here, the order of execution would be exactly before, after, and inside. Set timeout 0 is usually it's a hack, but having set timeout 0 and removing this set timeout 0 is basically 2 completely different code bases, right? So what I would like us to focus on is try to cut out all the things, all the pieces that will have async APIs, right? So set timeout is one example, set interval, events, promise.then, promise.catch, what else? WebSockets, and reactive streams callbacks. These are only the APIs that will have async callbacks. I basically need to know which are async and then to cut them off so that this code is not executed together with what is being wrapped with, but is going to form a separate message on the queue. And there is one structure called a message queue. There is another structure called event loop. Event loop is going to basically take one thing, do one thing at one time, and is basically going to rotate. If there are no messages in the queue, simply idle, doing nothing, unless there is a new thing. We have a lot of consequences coming from here. This is a FIFO queue. So if there is a lot of messages waiting already, and I would like a message to be scheduled, let's say within 1 second, and this 1 second has already passed, but this message didn't come to the front of the queue, then it has to wait, right? There is no way to kick into the queue. It basically has to wait. So whenever JavaScript waits, set timeout, set interval do not guarantee that it would be exact 1 second, because we would have to basically throw out the current task away. And we have 2 possibilities. The preemptive concurrency, which we have in, for instance, operating systems, can throw out a task, a thread, for instance, blue screen of death in Windows is an example. Whatever we've been doing, go out and we will display you the blue screen, right? However, the second option is cooperative concurrency in JavaScript. So the tasks are, there are no more important or less important tasks, or all tasks are the same, are of the same importance. So if one task has got into the queue, there is basically no way to throw it out. So if you have lots of tasks scheduled here, there is no way to get rid of them if they already touched message queue. So if you have any performance issues, be aware of the structure that you have here. Try to find if you didn't schedule too much things before. So if we have set interval or set timeout or events, they do not guarantee the exact time, they guarantee the at least time. This is just a consequence of the cooperative concurrency. So let's take a look at this code. What the order of execution is going to be in this case. Depending on
how many messages there are in the queue?
It depends on how many messages are there in the queue. The message I'm trying to get through to you is we can deterministically define how many messages there are. Like in case of events, it would depend how many times would a user click a button, but here there are no clicks and there are no WebSocket events. So here we can determine how many events there are. And the thing is that this is the first message, right? Basically cut out everything that is asynchronous. You might be wondering why this one, this fluffy, funny syntax is not considered async. Basically, it's an old thing from ES5 times. It's called immediately invoked function expression. If it's immediately invoked, then it means it's synchronous, right? Because immediately means I'm not waiting for anything. So basically, at this point, I can see that I have a function expression. If I'm trying to invoke it, probably it's a function. In the runtime, it turns out, yes, it is a function. So we're doing all the stuff internally. After I'm finished, I'll just go here. So I'm trying to find what is asynchronous here. And it's basically one set timeout and another set timeout. So the only stuff that is async, I'm trying to cut away. This is the first message that will go to the queue. So we'll have immediately 1, 4, and 5. Then we'll have the two functions, the two competing functions here, waiting in the timer. The first one that will be ready to execute is, of course, the set timeout 0. So this will be the next message. And now we will wait until this 1 second has passed and it's console log 2. Obviously, you would not necessarily have such code in your application, but that's basically the way how to figure out what is going to be the order of execution. Yes?
Small question, because
Sure.
the previous slide you said it's if the event loop has a lot of function messages in it.
Yes?
Will then, let's say 1 second has passed.
Yes.
Will the order of 2 and 3 still be guaranteed, or
Okay.
would that not matter anymore?
Okay. It's not possible to speak about all the details here. The question was, if there are a lot of messages here, could the amount of messages like affect the order of execution? Basically, whether we have timers or whether we have external requests or we have GUI event handlers and so on and so forth, all of them have their own APIs. So basically, when I'm doing a set timeout or if I'm doing an HTTP request, these messages don't reach the queue immediately, but all of them have some kind of condition functions, whether they're ready to be executed or not. In terms of functions of timers, it's basically whether the time has passed already or not. In terms of HTTP, did the client have the client already received the response or not? So basically, there is always a condition which might not be fulfilled yet. When this condition is fulfilled, the task reaches the queue, and from this point on, it cannot be removed, and the order is guaranteed. So in this case, In this simple case, we can see that it doesn't depend on anything. But what what I would like you to remember from this talk is try to basically cut out the things, because if you think about code this way, it's going to be really easy to reason about the order. That's one thing. The other thing, there is a simplification that JavaScript developers or developers from Python, PHP, Java, and so on and so forth, they make an error saying that setTimeout is an asynchronous function, that it's called asynchronously. Is it true or not? No, because I'm scheduling the task to be completed right now. I'm scheduling it right now so that it can be executed later on. Like, there is a very big difference. So setTimeout is not jumped over, only its callback is jumped over, right? It also makes a pretty big difference. So basically, in terms of functions, in terms of callbacks, that's pretty much it. If we try to use callbacks as it is, we can fall into traps like this, that we wrap a callback within a callback within a callback. This is called callback hell. This code is taken from callbackhell.com. Welcome to JavaScript. So we might say that callback is an architecture like big ball of mud. So not necessarily any architecture at all. The biggest problem here is that when I read this code, it could be started like this, and then I jump to the closing braces, then I read a bit here, and then I need to jump over there. So I'm jumping through this code, right? It works in a deterministic way, but there is a huge difference between what was the intention of the code and the way I'm reading it. This difference is so big that we had to come up with a better representation, and this way we get to promises. So a promise is an operation that will be fulfilled, that will be completed in future, but we already know what do we want to do with it, right? So if we were waiting for something and we knew what the next steps would be, we would have to wait. We don't want to wait because we have only one thread in JavaScript. So we schedule all the next steps, but we can proceed to do later stuff. So basically, it could be fetch some data, and then when it's positively resolved, we can call the callback function. When there is any exception, if there is something wrong going on, then we will basically call an error handler. Or we could use built-in stuff, like for instance HTTP requests, but we could also wrap our application logic with promises. For instance, one model representing a form could represent the fact that user would come to the form, fill it in, the form would be validated, and a process would be finished. Or I would have a multiple-step form, like I walk into a banking interface, and I want to schedule a transfer, and it's let's say three steps, 3 forms to fill, or 4 forms to fill. Something I need to pass my token, I need to confirm, I need to make sure that I choose the appropriate bank account, and so on and so forth. So I could represent a whole process of smaller promises to finish all the stuff, right? So we are trying to represent bigger things using smaller pieces. Promise have three states. So basically, promise is an object that we can schedule. What should we do if it completes, or what should we do if it fails, in short. So once initially the project, promise is pending. Once it settles down, either it can call the then callback or the catch callback. Once the promise is settled, we cannot change the state, because if the promise has fulfilled, then it means that all the then callbacks would be executed, and if we wanted to change the state, it would mean we would have to revoke an execution of function, which our processors don't allow us to do, and if we wanted to simulate it, it would be super cumbersome. So basically, a promise state is immutable. Once it's settled, it cannot be revoked. There is a lot to say about promises and the resources are easily achievable in internet. What I would like to say about is promises are very much limited. They're very easy to use. And I believe you might find yourself in situations, like 80% of situations, promises would be good enough. But sometimes their limitations would make your code very clumsy and make you think about whether JavaScript is a good language or not. So basically, promises might need a better representation. Promises can represent only a single item. So if I need to make multiple requests to the server, I need multiple promises. I cannot represent multiple things using one promise. It means I would need to make sure about the reference to the first promise, the reference to the second promise. I cannot just have one reference. This might introduce some overhead. The second thing, it's a one-time item. So if I need to represent multiple things, I would need to have multiple promises. If I want to repeat something, I need also to do this again using next promise object. Promises are greedy. This means that if I want to, let's say, represent an HTTP request using a promise, it means if I have the promise, it means it's already running. It's a kind of a task that does not have a start button. The start button has already been pressed. So basically, promises cannot be made lazy. We can only wrap promises with a function call, but it's like trying to overcome something from the outside. Promises are basically greedy. We need to make sure about whether a promise has already been called or not, depending on if we want to make something sequential or parallel. We'll see it in a while. Promises are not cancelable in current promises shape in ES6. So if we want to cancel a request, the best we can do is basically ignore the response that comes in, but there is no way to cancel it. There is an ongoing proposal, an ABER controller, to fix the issue, but it's not official at the moment. The values inside the promise chain can basically pass only one value from step A to step B. The idea of a promise chain is that the result of step 1 is going to become the input of step 2. The result of step 2 is becoming the input of step 3, so we can only pass one value. It's nice in a lot of situations, but if we happen to have a situation in which I need to access not only the previous value, but previous or previous value, there is basically no way to do it. We could wrap promises, but it's considered to be a very, very bad practice, and it basically breaks the whole idea of promises to be chained. So I can only pass one value. Also, values are unavailable outside the promise chain, which means if I create a promise, then the only way to access the value inside is to attach a then callback. If I would like to, let's say, start a process, a request, and I would like to use the promise, I cannot use the promise object because itself it could be made in future. It's asynchronous, meaning it will eventually become available. And the only point when we have a guarantee that it has been fulfilled is the then callback. So basically we have to unwrap the promise using the then callback. So there are pretty much many limitations. So let's assume that async op1 is a function that returns a promise. The idea to chain promises is to call the then function. Async op2 will either return some data or would return another promise. We can chain them together, right? So first do one thing, then when it's completed do another thing, then do the third thing, and so on and so forth. If this piece of code would be needed to be reusable, we can basically wrap it in a function, and this is what we call a promise chain. So basically it's a thread, it's a story of a sequence of operations, async operations, right? If we've been wondering what is going to be the order and how many tasks on the message queue we would have, it would be the first one is being scheduled immediately, right? The next step is going to be scheduled immediately. The next step is going to be scheduled immediately. and the final step is going to be scheduled immediately. This is the first task on the message queue. And then, once the first step is done, this is the second message, then this is the third message, and this is the fourth message. So basically, I cannot read the code as it would be executed linearly, right? Also, if you debug the code, you would see that JavaScript is jumping, not through the files, but even within one file, because the values become available throughout the time. So what we can see here is actually sequential processing, meaning when I have operation 1 completed, then I can go forward to operation 2, then I can go forward to operation 3 and to operation 4. I can wrap the whole thing in a function, which means if I would like the whole process to be represented as one thing, I can do a function call, and then what is going to be represented, returned from here is basically the result of the last promise in the chain. This way I can do scalable solutions based on promises. But, as we've said, if I have a value that is wrapped within async op1, there is no possibility to access it within this scope of this braces. I have to manually call the then function so that I can get the value from inside. Also, there is going to be only one value passed from these steps. If async op4 would require a value from async op1, there is basically no syntax to do it, no possibility to do it. Sometimes this is a problem. So that was sequential processing, and now let's talk about concurrent processing. Before I've said that if we have a promise, let's say in a variable or in an array, whatever, it means that the promise is already running. So if I start 4 different operations represented by 4 promises, and I have them together at some point in time, this means they're running in parallel. And what I can do is to use something that is called promise.all from the ES6 standard, which means I will proceed further once all the promises have successfully completed. If at least one of them fails, then the whole thing failed because the condition that all of them succeed is not possible anymore. So basically, I can wrap them. Also, I can wrap this in a function so that I can reuse it later. Basically, the order in which I wrap the promises with promise all is going to be reflected here, so that this single promise will resolve with one value, because it's always one value, but it's just going to be array of 4 items. The result of P1, result of P2, result of P3, and result of P4, never mind the order they had. What I've said in the beginning about race conditions, promise all is one of the most, let's say, fundamental ways to deal with race conditions. I don't know which one of them is going to finish the earliest, which one is going to finish as the last one. We have more promise aggregates. Promise.all is built into the language and into the standard. Its condition is all promises have to succeed so that the final promise succeeds. So as you can see here in this then callback, there is one value which is an array. If any of these promises fail, then we fail the whole thing immediately, and there is only one reason for the first item that has failed. We have also promise.race, which is not that much often used, but promise.race also wraps multiple promises. All promise aggregates are going to wrap multiple promises. Race is awaiting the first promise to settle in any way. So if the first of these promises succeed, then the whole thing succeeds with this value. But if the first promise fails, then the whole thing fails as well. So do not make a mistake and confuse it with promise.any, which awaits the first to succeed. It's not yet in the standard. It's available, for instance, in Bluebird library, but it's going to be available in the standard soon. Promise.any is awaiting the first one, any of these, to succeed. So if the first fails, second fails, the third fail, then still the fourth one can succeed, right? So we are still in the game. But in promise race, the first one that settles anyway will settle the whole thing, right? And we have also lots of more aggregates. For instance, promise.sum will accept a number that will say, I need at least 2 of these promises to succeed. Once it's done, then we can call. Then if, let's say, 3 out of 4 promises fail, then having 2 succeeded is not possible anymore, so we fail with the catch. You can imagine that there will be a lot more of these promise aggregates, and they basically define different ways to deal with concurrency. So I mentioned that there are limitations in promises, and this is the reason that JavaScript, one of the reasons that JavaScript introduced a yield keyword. It's like we have this sign on the road and we need to pass the control to the other side. It works exactly the same way. So in JavaScript, if I have a function that I would return, just an ordinary function I would return an array from, I can iterate over it so that I can basically do console logs, whatever. If I have a generator, which is a function with the asterisk, this is the generator, I do not return the values, I yield the values from the function, which means the generator is going to suspend, like go to sleep and do nothing. When the piece of code that holds the generator will ask, give me the next thing, then basically this control flow will wake up at this point, do the stuff until it touches another yield or return, and then go back to sleep again. Generators are a syntax to implement iterators, basically, and these are synchronous. We might do async iterators if we need, but basically they're synchronous by default. So this is just something that we can use. Like we can use iterators on backend to reduce the amount of RAM that we need to do some calculations. We might not need this in the browser. We would need it a lot in Node.js. But what we do need generators for, like here we can see that we can see an example. If we call a generator, we get the iterator. Iterator has a method next. We can see that we have outside. Then when we call next, then we have one inside. Then it yields A, goes to sleep. This yield is not used here. Then the control flow goes again outside. Then when we call next, it's going to wake up. It's going to do console log to inside, yield, and then we have 3 outside. So a generator is a function that basically goes to sleep when it happens on a yield. So until ES5 functions, JavaScript functions had to terminate, had to finish, like either it throws an exception or it basically returns something, and generators can yield a value, go to sleep, and then be resumed again. What we do need generators for is to combine them with promises. Imagine that we yield a promise. So the generator will go to sleep when we are waiting for a promises to settle. And once the promise is waiting to settle down, some other piece of code might be executing. And we would get a lot better API. And this is called a coroutine. So we start immediately. So it's greedy, just like promises are greedy. And when we yield a promise, we suspend on the promise, and as long as this promise is pending, the generator is asleep. So promise is pending, and when the promise resolves or rejects, we call next, so we resume the generator, and we basically go further and further. And resume when we settle. When we happen to yield another promise, then we basically need to suspend on the promise again. So promises and generators form coroutines, but they need the bridge. Async await is going to be basically the same bridge. So this is the one tiny wrapper. So it's basically writing async code, but in a linear manner, and we don't need to do the .then calls, which is pretty awesome and solves a lot of issues. So what we've had in a promise chain was basically doing promise.then. We had to think about the promise API. We could pass only one thing throughout the promise chain, and we could not access a value from the promise outside the promise. And here we don't have any of these issues. That's the cool thing about coroutines. So basically, if I yield an async op, from my point of view, from a developer point of view, JavaScript is just going to sleep at yield. When this promise resolves, it's just going to wake up, and v1 is not going to be the promise. It's going to be the value like ripped out from the promise. So it might be a JSON. So it's really, really cool. There is a lot of magic going on beneath, but it's really, really cool. And as you can see, at any of these points, I can access all the variables from this scope. So all the limitations we've had are not here anymore. The same way, I can wrap such a coroutine with a function to call it later. This async is the wrapper. So here we have sequential processing. If I yield this promise, it means I cannot go further, right? So it's sequential. I have to finish line 1 so that I can proceed to line 2. So all the yields are places that I basically sleep on. So this is sequential processing we've seen before. Also, I can wrap it in a function. If I wanted to do parallel processing, I would need to have multiple promises in variables or in an array, doesn't matter. So this is what I would do. As you can see, async op1 not being yielded is just a promise, right? Syntactically, it's just a promise. So the trick is to yield it later, right? Because if I reach this point, it means all the promises are already parallelly being executed. And if I yield them right now, they have been already executed and started concurrently, right? I don't have to think about promise.all, which wraps promises in an array and unwraps them in an array. I can do here pretty much anything that I want. I could do function calls. I could wrap it in another structure. I can add, subtract, divide, multiply, do anything I want without this addition of promise stuff. But I just need to know the syntax. So, as I said, promises and generators would not fit together out of the box. We need to get them this additional wrapper. So what the community has come up with is basically to introduce this as a new proposal to the language. You might know that since ES5 there is a new version of JavaScript each year. Some versions are pretty small, some of them are really huge and enormous. JavaScript is becoming as complicated as C# or Java. It's a really like fast language, very fast in development. So since 2017, we have what is called async await. So basically, we remove the asterisk from the function, making it an async function. Async function means this function will be executed in an asynchronous manner, means it will stop at some point. And instead of yield, we have await. And that's the only difference. Now I don't need to, this is sequential processing, I don't need to wrap it in anything. So basically, an async function is basically built into the language, built into the browser. This is super useful if you're not doing things like, please give me some JSON or give me HTML and basically drop it into the DOM. If you're doing anything more than this, async functions are the way to go. Also, they are executed faster in the browser than native promises, according to the Chrome team. So it's also, even though this mechanism is more complex than promises, in internal implementation, it might be executed faster, and in fact, it is, according to V8 authors from Google Chrome. And we've got concurrent processing. So basically, if I have a promise that I yield or await, it's going to return a value. If I don't yield, don't await it, it's going to be just a promise. If I have multiple promises in one hand, it means that they are basically running concurrently. I can await them later, yield them later, etc., etc. And we have concurrent processing. I need to speed up a little bit. I would like to show you a use case of async await, maybe as the last thing today. Let's imagine that we have a transfer interface, a banking interface. I would like to schedule a new transfer. I'm waiting for some stuff to display a form. I'm waiting again, I'm waiting for something all the time. I'm filling in the data into the form. I'm clicking for the user to continue. Then I'm waiting for the server to reload. I'm waiting for the user to confirm the transfer, to click it. Then I'm waiting for the user to see the confirmation that this transfer has actually been scheduled. So what we would, and finally, I'm waiting for the list of transfers to reload. There is a lot of code to be done with callbacks or with async or with promises, and it's a perfect match for Async 08. We can see a pseudocode here written in TypeScript. Let's say that this is our model that will ask to begin a transfer. There would be a transfer ID wrapped in promise returned from the server. There would be set transfer details, so which transfer and whom shall I pay, when, from which account, and so on and so forth. And finally, confirm transfer, that the client accept that this transfer should be actually scheduled. So what we can, the way we could possibly represent this flow is the scheduled transfer with a component, visual component, whether it's React, Angular, never mind. Let transfer ID equal await model begin transfer. I'm awaiting the server to respond what is the transfer ID that I have started. So I'm waiting for the server to respond. Now, when it's displayed, I'm awaiting for the user to complete step 1. Here I might have validation and other stuff. So I'm waiting for the user to input the data and to click it. Once it's done, I can set the transfer details, so I'm waiting for the server to respond. When the data is displayed, I'm awaiting for the user to complete step 2. Right? So I'm waiting basically for the user to click the submit button. I'm waiting it. Now I'm awaiting again the server to confirm the transfer. Right? After it's done, then the whole thing is done. And I'm awaiting for the user to click OK. I do acknowledge that this transfer has been scheduled. And finally, I can return the transfer ID so that the application, the outside of this piece, can know what has happened. Like if I want to represent the whole transfer being scheduled successfully, I need to have a value. Potentially I can use it or not, but I need to return something. Async function is going to return a promise. Async function is the same as a promise chain, but without the limitations of promise chains. So I just return transfer ID being wrapped with a promise. So if I want to access multiple values within the chain, I can just reach to the variables in the scope, which in case of promises, like there is no syntax to write it, right? There is basically no way. And it's a pretty often use case. Another thing, imagine if I wanted to write an if here, so do a step conditionally. There is no if then, no such thing, because if I have a promise chain, I do know what are the next steps up front. But if something will happen in runtime to know if this should happen or not, then there is no syntax to do it. Or if, let's say, I was pinging a server, please give me the response, or is it already, I want to have some data, it's not known yet, so I will ping you again, and ping you again, and ping you again, unless it's finally done. So I would have a while loop, unless the data that is being returned is available. Again, no way to write it in this way. And here within an Async 08, I can just write a while with a Boolean condition, whatever. I can do pretty much what I want, including try, catch, finally, blocks. So async code has become a lot easier thanks to Async 08. Unfortunately, I cannot tell about lots of other things that I've had ready here. Maybe next time. If I wanted you to remember the most important things from this talk is, please remember that some functions are being called in a synchronous manner if the data is available. If the data is available, there is absolutely no need to schedule it to be called later. Event loop is the mechanism that will basically take one message that is ready, execute it, run it until it's complete, and only when it's complete it will take the next message out of the queue and execute this one message, and so on and so forth, one at a time only. Callbacks is the first architecture we might use in order to make things running if things are easy. But it's going to introduce a lot of, let's say, noise into the code, make it unscalable and so forth. If we have single operations, we can use promises. For instance, I need to make a call to the request, and when the request is done, I basically paste it into the DOM. I don't need anything more than promises. But if I need, let's say, a sequence of operations, sooner or later, it will become easier for me to use coroutines or basically async await since it's already baked into the browser. The thing is, all that we see here on the right-hand side, these are operations being executed once. Only once. But if something is repetitive, promises, I need another promise instance, I need another promise object. Promise would basically not fit. I need events. The thing with events is a trouble that if the event has already been scheduled and I would like to react to this event with doing add event listener as a consequence of another event, I would have a huge amount of problems to add the event listeners, remove them concurrently in all kind of, let's say, orders that are potentially possible. That would be really, really freaking difficult. And this is the reason for reactive streams to come here. Unfortunately, we have run out of time, but reactive streams is basically RxJS. It came from C# like Rx.NET. It has implementations in all languages used in business, like RxJS, Rx.NET, RxJava, RxPHP also. It's something very trendy and very hot because it redefines what a variable is. Basically, imagine that you have a variable. If you have a variable, I can push a value to the variable. But if the variable value changes, I don't know about it, right? So in one sentence, what are reactive streams about? Imagine that a variable notifies you whenever its value changes. Each variable becomes an observer that pushes events, and everything becomes an observer, and everything pushes value. There is a global inversion of control throughout your code. You have event emitters everywhere. This might be scary or difficult and a lot more complex, way more complex than events, but actually if you have complex applications, it really helps. I hope that after this presentation you have a big overview of what is available, and that maybe you have refreshed your knowledge about JavaScript. Thank you very much for your time, and yeah, if you have any questions, come to me. Thank you.